Hey, folks. Uh, we're going to do one type of transformation today, and it's dilation, making something larger or smaller. And you might wonder, why am I sharing this screen with you about editing your photos? Well, a good photo technique would be, see how the horizon here is at an angle. I mean, water is not going to run down from left to right unless it's going down a waterfall. And this looks like a picture of a lake. So one technique that's important in photography is the horizon should be completely horizontal with your photo. So this right here is what they would call a rotation. We're going to do a rotation. So let's set up our notes, put the video on pause, and I'm going to list a few transformations just to kind of get our minds working, like what is the transformation, and get you in the ballpark at what we're going to be doing this whole chapter. So like I said, put the video on pause, set up your notes, and come on back. Thanks for doing that. Here's what we just said. Rotation is one type of transformation. So let's put that over here. You might need to take your photo and rotate it. Okay, and we need to know what a positive and negative angle rotation is for mathematics, and we're not going to get into that for this chapter. That's not the most important one. Let me show you another transformation being done to photos. Sometimes you want to focus on a particular spot in your photo, so we would kind of zoom in on that spot by cropping our photo. Now, when you crop it, generally speaking, the photo isn't going to be smaller over here. The program takes that part of your photo and then enlarges it back to the original size. So like if you wanted to see that photo right on your phone, you click on it and it fills up the screen on your phone. It doesn't just show like a certain part of your photo and the rest of your phone is black. So this is going to be a dilation. It's going to take this part of the picture and enlarge it to, back to the original dimensions. Like if it's, 4 inches by 6 inches, it's going to take this little tiny piece and make it 4 inches by, or 4 inches by 6 inches. It's going to enlarge that little area. So that kind of enlargement is called a dilation. Okay, dilation. That's the one we're going to be focusing on for section 1. Now, why are we going to focus on dilation and not rotation? Or you've heard of reflections, right, in transformations, or maybe you've heard of slides or translations. They sometimes avoid the word translation because it's so close to transformation. So a translation or a slide is just moving over. If you just moved over in your photo, you might take your camera and just rotate so that you're moving over in your images. So anyways, why are we focused on dilations? Because this whole chapter is going to be about similarity. So are these two triangles down here similar to each other? Well, that would have to do with what's called a scale factor. And so when we figure out, well, how much smaller is the triangle on the right than the one on the left? So that's the question. Is it an enlargement, or is it let's look over at our homework, okay, for a second. So I just want to show you this. See, it says, is it an enlargement or a reduction? So in this question right here, it's going to say that. It's going to say, is this an enlargement or reduction? Well, I mean, the green triangle is smaller than the blue triangle because they wanted us to go from left to right. In the directions, it says that right over here. When you go from the left one to the figure on the right, is it getting smaller on the right or larger on the right? Well, the one on the right is smaller. So it's a reduction. Okay, so that's a pretty easy question. Is it getting bigger or smaller? Okay. And so you just look from left to right. Why do I look from left to right? Because that's what the direction said. And then to figure out what the scale factor is, let's look in here. It says find the scale factor. You're going to take the one on the right divided by the one on the left. So let's put that down in our notes. The one on the right divided by the one on the left. Why am I suggesting that? Well, I think they're implying that when we go from left to right, this is what's called the image over here. This is called the image. And this one's the pre-image. This is where we started. This is like our initial photograph. And now we want to reduce the size of this triangle down. And this is our new image. So you take the image divided by the pre-image to figure out the scale factor. Okay. So where did we start? we're gonna divide that into where we ended up. So 12 is going to be in the denominator and 6 is going to be in the numerator. So the scale factor comes out to be 1/2. See this number over here, the scale factor is going to be smaller than 1 if you have a reduction going on, right? So that's called scale factor. That's maybe such an important word. You may want to put that right over here in your topic. I'm off on. I was trying to do two things at one time here. I'm off my spelling. So it's the scale factor, not the scale fraction. Scale factor, okay, and that's right over there. Now, this right over left, it might not always go like that. They might not always put the pre-image on the left and the image on the right. So I'm going to put a little bubble around this guy because that is always true. You're going to take the modified figure divided by the original figure, and that's going to give you your scale factor, okay? Now, look, over here on problem number 5, I just put a line through 5, but this is going to be your 5th problem. So the first 4 are just like this, but on number 5, it changes. They give you these points, and sometimes we feel like, oh, no, I need, GeoGebra. Well, let's just look at GeoGebra for a second, okay? I put them in all 3 of the points, and now I want to do a dilation. So let's go over here to more, and let's look down for transformations down here, okay? See, transform. I guess they leave off the ATION, but transform. And see this? Dilate. Okay, so dilate. Now, it says from a point, because all dilations, you need to have like a center of dilation. So let's look back at the problem in our homework, okay? And when I do that on problem number 5, it says the set of points, find the coordinates, the vertices of the image, see, image right there. That's after we've done some transformation. After a dilation by the given scale factor with a center and a center of dilation. So see how it says center is at the origin, center at the origin. So I'm going to go over here to my GeoGebra, and I'm going to click on not reflect, not rotate, but dilate. And it says select object, then center point, then enter factor. That factor thing, let me click on it again because if it goes too fast, we can't read it. So it says dilate from a point. Select object, then center, then enter factor. They mean scale factor. They leave off the word scale. That's not important probably. So it says, I think it said select the figure that I want. So shoot, let me try this again. I click on it, it says select object. Ew. Okay, so if I want this to stay as a triangle, I've got to say polygon. And then I'm going to select the points over here, okay? This isn't going to be that difficult on all these problems, but I'm going to select the polygon. Now I'm going to go dilate, and it says select object. Okay, maybe I can select in the middle. Yes, see how I got everything now? Then I select the origin over here. Now I don't know if it's going to let me do this. I've got the hand right there at the origin, but I might need to make a point there. Let's see what it does. Did it do it? It didn't do it. See that? So I need to go back up here, and I need to choose point. And now I'm going to put a point right at the origin. Now, I hope the snap to grid is on. Is that point right at the origin? I think it is. Okay, I think we're going to be okay. So let's go back down here. I appreciate your patience here. I'm going to go to dilate. It says select object, select point, and then I enter the scale factor. Now, what was my scale factor again? I think it was 1/2, 0.5. Okay, I think you could type in 1/2 over here. 1 divided by 2. Divide by is right near the shift key. Okay, let's see if it takes a fraction. But you could also turn the calculator on, right? I hit OK. Oh, look at that. Is this a reduction? Well, yeah, the triangle got smaller. Now let's see if we can make some conclusions here. You notice how it has a little prime on it. So I'm going to come back over here, and I want to put down JKL just a second here. So we had this triangle like this, right? And it was J, K, and L. And now I've got this new triangle, J prime, K prime, L prime. Let me switch colors here. Now I've got this new one. It's kind of like this. And they have a J prime, a little tick mark on it, and a K with a little tick mark. That means prime. And then an L with a little tick mark means a prime. Means that this is the image. This is the pre-image. The image is in red, okay? And the pre-image is in black. So let's put that down over here. Pre-image. The image is in red. The pre-image is in black. So what just happened? This point was 8, 0. And now the red point over here, its corresponding point right there is at, it was negative. Shoot. It's at -4, 0. Let me squeeze a negative in this ordered pair over here. So didn't the number just get cut in half? -8 became -4, 0. Well, you cut 0 in half, it's still 0. Let's try it with a k point right up there. So k was at -4, 4. Now it's at -2, 2. It's definitely just getting the point cut in half, right? So this is at oh, shoot, I want this at -4, 4. And then this one over here is going to be a -2, 2. Okay, so the image is just half the numbers of the pre-image. That works if your center of dilation is the origin. Be careful on the other homework problems, because if the center of dilation is not the origin, we need to move that point. So you'll look for the move. Where's the move at? Probably down. Oh boy, shoot, I lost where the move is located. Oh no, I think we can just grab, oh, there it is right there. Yeah. So I'm going to grab this point and I'm going to move it somewhere else. Oh, because it's stuck on the origin and won't let me move it. So you might need to just do a, flat out new setup for your drawing if it asks you to dilate around some other point than the origin. If it's asking about the origin, you just multiply by the scale factor. So let me just see if I can make that clear back here on the drawing. See, if I just multiply by 0.5 on each one of these numbers, see, J prime is going to be at negative, oh shoot, I don't need a parenthesis, -4, comma 0. So I just took half of that -8 and half of the 0 and put them in. That only works if it's at the center of the origin. So I want you to add some notes down here, because I talked about the origin. I talked about using GeoGebra. You add some stuff, do the other problems. Thanks for watching my video.